This is section 1 of chapter 2. This lesson is on real numbers and number lines. We're going to focus on the real numbers part in this video. We'll get to the number lines in a different video. So we're going to talk about different types of number systems. The first type of number system we're going to look at is the natural numbers. These are considered the counting numbers. So for example, the first number would be 1, and then the next one would be 2, and you just keep counting by 1 for as long as you want. So the ... dots mean that we can count forever by 1 to infinity. This is the set of numbers that you understood first. So when you were a little kid, you didn't really have a good concept of the numbers 0 or negatives or decimals or fractions. So the natural numbers, you understood the numbers 1, 2, 3, 4, so on and so forth. So any number that's a natural number is going to live in this set of numbers, and we're going to use this fancy looking n. So it kind of has a double leg on the left. When you see this fancy looking n, that means the number is part of the natural number system. The next set of numbers are the whole numbers. Whole numbers include the number 0 and all of the natural numbers. So it has one extra number in this set, and that's 0. So 0 is a whole number, so is 1 and 2 and 3 and so on and so forth. That fancy W refers to the whole number system. So if you are a whole number, you live in that number system. Now we're getting into some different types of numbers that you may not understand maybe as well as you would like. Integers would be the number 0, all of the positive natural numbers, all the way up to infinity, and all of the negative natural numbers. So that's why we have the dots coming before this. We go all the way to negative infinity that way as well. So the set of integers includes the negatives. Whole numbers they do not have negatives in them. Okay, now this might seem weird, but the special letter that you're going to use for the integer set is a Z. So that special looking Z with that double leg in the middle, that's the integer set. So if you're any one of these numbers, you live in that integer set. That next set of numbers that we're going to look at are called rational numbers. For rational numbers, again, this is going to seem weird, but you're going to use this special Q for rational. Rational numbers are any number that can be written as a fraction. If it's a fraction, then it's a rational number. So for example, you could definitely write -1 as a fraction. You could write it as -1/1 if you wanted to. Also, -3/4 is a fraction. Don't forget, there's infinitely many other fractions that live in between those two values. So on and so forth all the way up. 0 is a rational number because it could be written as a fraction. So is +3/8. And all of the numbers in between 3/8 and 2/3. These are all rational numbers. You can always find another number in between these two. So our rational number set has all of the numbers from the integer set plus all of the positive and negative fractions that go in between. So here's some other information about your rational numbers. 3/8 is a number that can be written as a fraction. Its decimal equivalent is 0.375. Negative 2/3 is negative 0.6, repeating forever. Notice how these decimals terminate. This one here is non-terminating, meaning it goes on forever. Terminating means it stops. Rational numbers can have terminating decimals or non-terminating decimals. But the idea is they have a repeating pattern. So even though this decimal goes on forever, I think you know what the next digit is, and the next digit after that, and the next digit after that. They're all sixes. Over here, it doesn't look like there's a digit here, but remember, there's really a 0 there, and another 0, and so on and so forth. Whether your decimal is terminating or non-terminating, if you know what number comes next, it's going to be a rational number because it's going to have a repeating pattern. So here are some examples of your terminating decimals because the decimals stop. These are some examples of non-terminating decimals because the decimals keep going. That's what the ... is for. So some of these have a repeating pattern. Notice how this one just keeps repeating that 3. That's a 1-digit repeating pattern. This decimal is repeating 2 digits, 17, 17, 17, 17, 17, so on and so forth. This number has a 3-digit repeating pattern. All of these numbers can be written as fractions, so they're rational. Some of them have terminating decimals or non-terminating decimals, but the idea is you know what's coming next if it's rational.